Hello everyone. We're taking a look at factoring trinomials with leading coefficient of 1. So we're in section R.5, and so let's look at an example. Let's say I have the following trinomial. I have x squared minus x minus 20. This is an appropriate problem because I have three terms. Here's my trinomial. It's in descending order, and it has a leading coefficient of 1. Remember, you can always throw a 1 out front. So I have 1x squared. Okay. To factor trinomials with a leading coefficient of 1, here's what you do. So first you take the constant term with the sign attached. So here's my constant term. Here's my constant term with the sign attached. I've got a minus 20. Then you want two numbers and multiply to the constant and add to the middle coefficient. So this is my constant. I'm looking for two numbers. They're going to multiply to this minus 20 and are going to add to the middle coefficient. So the middle coefficient would be here. My middle coefficient would be a minus 1. Again, with the sign attached. So this is minus attached to that coefficient. So I'm looking for numbers that multiply to minus 20 and add to minus 1. So factors of minus 20. You got 1 and 20, 2 and 10, 5 and 4. Oh, that'll work. You got a minus 5 and a 4. Right? Quick check. If I take minus 5 times 4, we get 20, negative. And if I add these two, minus 5 plus 4, I get the minus 1. And then that's how they're going to factor. So x squared minus x minus 20 factors 2, and use parentheses because you're factoring, you're going to get a product. You get x minus 5, parenthesis, parenthesis, x plus 4. These two numbers are how it's going to factor. So let's look at another example. Okay, factor. Those are good directions. It doesn't say solve, it says to factor. So let's try this. I got x squared minus 10x plus 25. So it starts off with an equal sign. So we've got a trinomial, and I have a leading coefficient of 1. So I take the constant term. I like to do this off to the side. So I got 25. I'm looking for two numbers, multiply 25 and add to minus 10. Well, since they're adding to negative and it has to multiply to positive, if it factors, I know both of them have to be negative. And 25 is pretty easy. You don't have that many factors. You got 1 and 25, that's not going to work. And 5 and 5. Oh, that'll do it. Minus 5 and minus 5. Minus 5 times minus 5 is 25. And minus 5 plus minus 5 is the minus 10. And then it's going to factor to x minus 5. X minus 5. And then when you're multiplying two of the same thing, I'm going to write that as quantity squared. And even more motivation that we can't distribute that exponent. It's x minus 5 quantity squared. If you were to FOIL that out, it gets you back to x squared minus 10x plus 25. Alright, let's look at one more. Okay, I lied. We're going to look at two more. So here's the first one. We'll try to factor this. I got x squared plus 8x plus 7. Okay, trinomial, leading coefficient of 1. I take the constant term, looking for two numbers, multiply 7 and add to 8. Now here it's obvious, but I did this one for a reason. Don't forget about the number and 1. That's a combination that most people forget about. So that's going to work. If I take 7 times 1, I get the 7. And if I do 7 plus 1, I get the 8. So this goes to x plus 7 and x plus 1. And remember, it doesn't matter the order in which you write them. That's also the same as x plus 1 times x plus 7. Makes no difference at all. We got it. It's factored. And you can FOIL out and make sure it's right. Okay, last one. Okay, let's try to factor this. I got x squared minus 4x plus 12. Trinomial, leading coefficient of 1. So I take the constant term. I got a plus 12. Looking for two numbers to multiply 12 and add to minus 4. So I know a lot of people are probably thinking, well, what about minus 6 and 2? Will that work out? And the answer is no. Because here the problem is if I multiply these two together, minus 6 times 2, that gives me a minus 12, which is not what we're looking for. We need a positive 12. In this case, I don't think any numbers are going to work. Let's see, 3 and 4, that's out. 12 and 1, 6 and 2. The problem is that I need something negative. I need them both to be negative if they're going to multiply it to a positive number. In here, none of the factors are going to work, so this guy is prime. It cannot be a factor. So watch out for that. Not everything factors. And that'll do it for this section.